In this video, we're going to look at a couple of exam style questions on using these new identities. And we're going to start with example 2. And the question says solve sine 2x plus cos x equal to 0 within radians between 0 and 2 pi. Imagine in the exam you see a question like this, like you've got one of the key things with trigonometry is you've got to understand like what technique you're going to be using and why. Like I won't be there saying, oh, we'll just use this identity. And like the first thing that sort of jumps out at me when I see this question is that this is a very unusual thing that you've probably never seen before up to this point. We've got two different angles. Okay, so we've got sine and we've got cos. We've solved equations with sine and cos in before, but this question, the first thing that really jumps out is that the angles are inconsistent. And if the angles are inconsistent, that's when the alarm bells go off and you should be thinking, right, compound angle identities, double angle identities. Okay, and what we can do is we can say, well, I know that sine 2 theta is equivalent to 2 sine theta cos theta. And by using that identity at the beginning, we can replace sine 2x with 2 sine x cos x plus cos x equal to 0, and now we've got an equation with a consistent angle, so we can begin to think about like now what comes next, how are we going to solve this. And once we got to this point, let's have a look. Okay, we've got two things and they're equal to 0. Mathematically we don't like that when they're both separate, so is there a common factor? Yeah, take cos x out. As soon as you factorise, we're in a much better place, aren't we? Two things times together and the answer is 0. You've been doing that for the last couple of years. If two things times together and the answer is 0, we can just think about them separately, can't we? So cos x is equal to 0. 2 sine x plus 1 would be equal to 0. Make sure you're in radians when you do this. Cos inverse is 0, we would get pi over 2. 2 pi minus answer would give us 3 pi over 2. For this one, just be careful. We've got sine x equals minus a half. Sine inverse and minus a half on your calculator, I think that should give us minus pi over 6. Let me just check that. Yeah. Pi minus answer. And that would give us 7 pi over 6. Between 0 and 2 pi, well, that one too small, so then just add on 2 pi to find the corresponding answer, and that would give us 12 sixths minus 1 sixth, so 11 pi over 6. So we get 4 answers altogether. Okay. Example 3 looks a little bit more challenging, but don't panic. Like, think about the format, like show this, solve this, okay? If you cannot show this, you can still solve this, because that stuff there that looks horrible, remember, we know is the same as sec squared. So in part B, we're just going to solve sec squared equals 4, okay? So let's look at part A first. What's going on? Right, this looks pretty horrific. We've got an identity. I'm going to start on the left hand side. I've got two separate terms. The final answer is one term. And obviously, like, alarm bells are going off here. There is essentially an inconsistent angle. Also, the fact that we've got cosec. And I've not taught you any double angle identities for cosec. So what could we do here? Let's think about this. Remember, the third letter tells us it's equivalent to, if it's cosec squared, it'd be the same as sine squared on the denominator, 2 theta. Cosec squared is just 1 over sine squared. Okay, so all I've done there is I've written it back in terms of something I'm more familiar with. Cosec, 1 over sine, cosec squared, 1 over sine squared. 4 cosec, 4 is just a 4, don't do anything with that. If it's cosec squared, it's 1 over sine squared, and the fact that it's 2 theta means it's 1 over sine squared, 2 theta. Okay. Now I'm still sort of a little bit worried that I've not got this consistent angle yet, but I can do something with this. Okay. So remember, sine squared, when we write that, we mean the whole thing is being squared. So sine 2 theta is being squared. Now I know that sine 2 theta is the same as 2 sine theta cos theta. And whenever I'm working with fractions, I'm always thinking, can I get a common denominator? Because what we're trying to end up with is just one single term, isn't it? So look what happens with this denominator. If we square this, we'd get 4 over 4 sine squared cos squared. We can cancel the 4's. That'll leave with 1 on top. And now we just need the common denominator. So this denominator's got sine squared and cos squared. This denominator's got sine squared. So we'll multiply this one by cos squared on the top and by cos squared on the bottom. And that'll give us a common denominator. Now we can combine the fractions. 1 minus cos squared over sine squared cos squared. Remember, a good piece of advice when you're doing these, look at what you're trying to get to and maybe work backwards a little bit. So we're trying to end up with sec squared, which is 1 over cos squared. And look at what we've got. How are we going to get that to cancel? A couple of ways we could do it, actually. Think about it. What do we know about 1 minus cos squared? We know sine squared plus cos squared is equivalent to 1. So 1 minus cos squared, that's just like having sine squared on the top, isn't it? So we could write that as sine squared divided by sine squared cos squared, and then we can cancel sine squared from the top and sine squared from the bottom, and we get what we wanted, sec squared theta. So obviously, hence, we want to use our previous answer. That stuff there, that horrific looking stuff, we know is the same as sec squared. So all we've got to do, I say all we've got to do, you still got to be careful here, but we're just going to solve sec squared equals 4. Do we need to use an identity now? No, because it's just something squared equals 4. So please don't forget when we square root, plus or minus. And then how do we solve sec? Well, we can replace it with cos, or 1 over cos, sorry. So if sec is equal to 2, that would mean cos theta would equal half. And if sec is equal to minus 2, that would mean cos would equal minus half, just by taking the reciprocal. Okay. We're solving between 0 and pi in radians. So take cos inverse of a half, that would give us pi over 3. You can try if you want. If you do 2 pi minus answer, it'd be too big. Okay. For this next one, maybe check. Just put my calculator into radians. So cos inverse of minus 0.5, and that would give me a 2 pi over 3. Again, 2 pi minus answer, it's going to be bigger than pi, so there's only 2 answers for this one. Okay. Okay, so I've skipped a couple of examples. You should be able to look at them using the booklet with the solutions on and figure it out from there. If not, just drop us an email and ask, and I'll send out some clarification. This one's a really important one for us to do, though. Okay, we're going to do a lot on compound angle, and double angle, triple angle, maybe even more when we get onto some further maths content. But for now, we're just going to look at sine 3 theta, cos 3 theta. We could do sine 4 theta, we could do sine 5 theta. This technique that we're going to use from A-level maths, it gets very messy if you want to do sine 4 theta, sine 5 theta. But once we've done something else in further maths, we'll be able to do it a bit quicker. But for now, while we're still revising the A-level content, if we were asked to express sine 3 theta in terms of sine theta, now what that means, don't forget, if it says in terms of, it means your final answer needs to just be sine thetas. We don't want any sine 3 thetas in our answer. I've given you a bit of a hint about how we're going to do this. Potentially pause it and try before I go through it. What we're going to be using is this compound angle identity. Okay, we could write sine 3 theta as the same as sine of 2 theta plus theta. And then if we split that up using this identity, so A, we could think about A as being 2 theta, B as being theta, that would be sine 2 theta cos theta plus cos 2 theta sine theta. Okay, we finished. No, it says express in terms of just sine theta, so I don't want to stop until my answer's just got sine theta in. Okay, let's think carefully about how we're going to do this then. Sine 2 theta, we haven't got a choice, have we? We know that that's equivalent to 2 sine theta. Cos theta multiplied by cos theta. The one that you've got to be careful with is this one, and while you're getting used to this topic, this is the one that causes a few issues for people. Cos 2 theta, remember we actually wrote 3 versions. It's cos squared minus sine squared. It's also 2 cos squared minus 1, and it's also 1 minus 2 sine squared. So just think carefully about which one you choose. Okay, we're aiming to get our answer with sine thetas in, so obviously we're going to use the one that's in terms of sine theta. Okay, so that would be 1 minus 2 sine squared theta multiplied by sine theta, and we're nearly there now. Okay, so this would give us 2 sine theta cos squared theta plus sine theta minus 2 sine cubed theta. So are we in terms of sine theta? Not quite. Last thing to replace is cos squared, and obviously we know that that would be the same as 1 minus sine squared. And that gives us 2 sine theta minus 2 sine cubed plus sine theta minus 2 sine cubed theta. Tidying it up, 3 sine theta minus 4 sine cubed theta. Okay. Very similar for the cos 3 theta one. Pause and have a go. Okay, so cos 3 theta, cos 2 theta plus theta, and then we can use this, so that'd be cos 2 theta cos theta, be careful, minus sine 2 theta sine theta. And then we want to get in terms of cos theta, we're stuck with double angles. Cos 2 theta, which one are we going to choose? Okay, we want it in terms of cos, so let's use 2 cos squared theta minus 1 multiplied by cos. Sine 2 theta, don't get a choice, 2 sine theta cos theta all times by sine theta. And that would give us 2 cos cubed theta minus cos theta minus 2 sine squared, sine times sine, so let's replace that with 1 minus cos squared times by cos. Just be careful with your negatives as you expand them. Minus 2 times by 1 times by cos. You might want to expand this not all in one go, but you end up with minus 2 cos theta. Minus 2 times by minus, that's going to be plus cos squared times cos, so plus 2 cos cubed theta. Final answer, 4 cos cubed minus 3 cos theta. Okay, so I'm not going to do any more examples. You should be able to figure them out just from looking at the word solutions. And this is a fairly challenging topic, just because there's so many different applications of those identities. So please obviously use the word solutions when I send them out and ask us if you need any help. But you should be able to have a good go at exercise 1 now, guys. Okay, and my advice would be just think about it like if you've got an equation where one's a 2 theta or one's a 2x and the other one's an x, you're obviously going to be thinking, right, can I use the double angle identities? If you've got like x plus 50 or x minus 30, then you'd be thinking, oh, it's something minus something, it's something plus something, so then you might want to use these compound angle identities. Okay, but yeah, as I say, let us know if you need any help. Thanks very much.